I'm recording now. All right. So let's talk logistics first. Final exam is Monday, 2 o'clock. So regular class time, first day of next week. Um, I strongly recommend you come into Zoom. Log in, come into the Zoom room as usual, and the exam will open up on Canvas at 2 o'clock. It'll be in the form of an assignment, not an online quiz. So you read through the questions, write up your answers, submit them as a PDF by the deadline. So unless you have extended time allowance, the regular deadline is 1:50. Canvas will not lock you out after that. So there's nothing physically stopping you from submitting late, but it's the 10 point per minute penalty if you submitted late. So if you're in doubt, submit along the way. If you have internet upload speed issues, submit a half hour before time is up, and then keep working and submit the extra work after that, right? And then you have a smaller upload and so on. You are right, 3:50, not 1:50. So exams from 2 o'clock to 3:50. No time travel required. Yeah, we can definitely go through. We can definitely go through client server, some sample code, and so on. I'm going to recommend again that before Monday afternoon, spend a little bit of time, get your tools nailed down, right? Figure out how you're going to type in code, turn it into a PDF that you can upload. And the gotchas are, using an editor that changes your indenting for you, using an editor that uppercases the first letter of every line, or, spell corrects print writer to something else, panda writer. Figure that stuff out, right? So that you don't have to be trying to debug your submission process during the exam. How would you use time travel most effectively to cheat? That's an interesting question. I mean, the legit way would be to go back and study differently, but there's so many other options. Travel past the exam, yeah. So yeah, Notepad, copy paste into Google Docs, download as PDF. Does sound like a bit of a process. You should be able to, from Windows, print from Notepad into a PDF. Yeah, exactly what someone just said. You should be able to print pretty much anything into a PDF, and that should get you there. Yeah, that's always a good option too. If you're Linux, you can use like A to PS that will convert from from ASCII to PostScript and then turn that into a PDF. I love time travel in Bill and Ted, where they like hide the wallet. Yeah, that's on the must-see list. All right, let's see other logistics. So you can use all of your notes. You can use all the code you've written and turned in for any of these classes. You can use your whole GitLab repo, right? I'm not limiting you on accessing your own resources. You can use the Java documentation from Oracle, and if you haven't downloaded that, you can go online just to look at that site. You can use the textbook, which I don't know if anybody's even looked at. You can use your own notes and so on and so forth. But Yeah, there is a textbook. It's like 1,000 pages too. It's a really good reference. But no other online sources. Obviously, no wiki, Stack Overflow, Course Hero, Chegg, etc., etc. Um, yeah, I like the book a lot too. Let's see. Plain text editor, syntax highlighting is okay, but don't use anything that corrects syntax. Don't use anything that auto fills in code for you. Don't use Eclipse, IntelliJ, etc., etc. Um, I'm gonna say download the code from the server so that you don't have to get onto the server. Um, just because that's a little cleaner and um, don't compile code, right? I don't want you putting code into Eclipse or doing Java C to check your syntax or anything like that. So classroom experience, right? Imagine you're sitting in a classroom and follow those rules. If you're in doubt, you can always ask, right? So I'll be in Zoom. Um, you can ping me and say, hey, is it okay if I do such and such, and I'll let you know. That would be a good loophole. Like if you're telepathic, is that cheating? That's also a valid point. And you had the voice option turned on, so it spoke out loud the syntax errors. All right. I think that's all there is for logistics. Again, mainly just be in the Zoom room during the exam, the regular room that you're in right now. And if there's any questions, concerns, right, just go ahead and ask during the test. If people find errors in the exam, which usually happens, I'll probably announce corrections along the way. So be logged in to take advantage of that. And topics, it's going to be more on the second half of the course. But, the first half of the course was really kind of learning the mechanics of Java and the kind of mindset of objects and classes and things like that. And you need to do all that stuff to, write code with scanners and sockets and all of this stuff. So you're using all the stuff from the earlier part of the course, in the later part. But my questions will probably be more related to the later topics. Yeah, I think that's about it. So mostly programming questions. I might have some short answer or conceptual kind of questions, but mostly it'll be short programming assignments. So either writing entire classes or a main method or a snippet of code or something like that. All right, I'm done eating. I can put my camera on. All right, so let's start with a review of client server business, since someone asked about that, and then we can go into general topics. Well, let me start with paper and see if this works. So the general client server model is you have a server side. This is some service that's hanging around running and waiting for connection requests. A client is a process that makes a connection to a server requesting some action to be performed. So On the server side, we have this server socket. With some particular port number associated with it. And we can just think of this as one machine for now, but we can talk about networks next. But on one machine, we have a server socket with some port number associated. 1234, right? For net dots or whatever. And a client can basically create a socket and specify a port number that you want this socket to connect to. So I would create a socket and say connect to port 1234. And if there's a server socket with that same port number somewhere, and the code that's created the server socket is in the middle of the accept method, then this will return a new socket. And this new socket and the socket that the client created will be connected to each other. Okay, that's the higher level view of what's going on. So we have a server socket which advertises a port number basically. A client creates a socket and says I want to connect to that same port number. The server calls accept, and accept returns a new socket, and that socket's connected to the client socket. And now, this communication can take place, and another client can say, hey, I want to talk to port, whatever this port number is. And if this server calls accept again, it will create a second socket, and that socket will connect to the second client, and so on. So that's the picture view of what's happening. The way we actually do this is, we make a server socket. Constructed with a port number, and then if we say, socket s equals ss.accept, right, this is going to be that new socket that gets returned by accept. And over here on the client side, we say socket, s equals new socket. And we don't just specify the port number, but we also specify the host ID, the machine that we want to connect to, because this is networked, right? So if we do localhost, then it's going to be the same, machine that the client is running on. But we could put in, 192.168. something something address, or linux.engrcs.com, or something that will identify a particular machine somewhere on the network, and then this will look for a server socket with that port number on that machine. And so, that's the networking part. So once we do this socket over here and this socket over here are connected together. And so now you do something like open a scanner on here and a print writer on here, and same thing over here. And if you write into the print writer here and you flush, then the scanner will read whatever was written when you do, scanner object.next line, for example. I would have a typo. And so there's some sample code in here. So that's a basic example of the server side. And oh yeah, so try catches, right? All of these things can throw exceptions. Trying to construct a server socket, if that port is in use, if it's privileged, and so on and so forth, you can get exceptions. So we put that call into a try catch. When we try to accept, we can get an exception from that, so we put that in a try catch. When we construct the scanner or the print writer, that can throw an exception, so we put that in a try catch. But this makes a server socket. This accepts a connection request and gives us a new socket that will be connected to the client socket, and then we use that socket. In this case, we're opening an input stream, making a scanner, and then we can just read whatever the client is sending us. That's totally true. Yeah, it's like, you know, 2 lines of code up here if you don't have all the try catches. And you can declare methods that throw exceptions. I could say that this main method can throw an exception, and then I don't need to put these try catches in. And you can see how sparse the code is. So that's the server side, and presumably there's a client side. We didn't do a whole lot of coding up with the client side, because we mostly hit this with telnet. But if we look at the threaded version, and don't worry too much about the threading, well, we have to worry about the threading. That's kind of a bummer. All right. Well, so this is really all there is to it, right? It's really one line. Just construct a socket with the host name, the port number, and then once you have that socket, exactly the same as we did on the server side, go ahead and construct, you know, a print writer and or a scanner, and write into the print writer, read from the scanner. If it's muddy, right, just sit down, write some code. Right, you can copy the server code if you like, but try to write it, you know, just with your understanding of what the client server does, or go through the code and make yourself some notes. Right, server socket does this, client does this, right? And then using those notes, try to write a server program that, I don't know, you know, takes a number and doubles it and returns twice the number or something. And try to write the client side, right? And that's generally a good way to prepare for tests in classes, I think, is, you know, make yourself note pages as you're studying, and then try to solve problems that might be similar to test problems using those note pages, right? Heading towards, you know, minimal number of notes, but, you know, notes are fine. So hopefully that helps a little bit with client server. All right, cool. Any other particulars that anyone wants to go through? Ta-da! So this is posted on Canvas, and this is just kind of a synopsis of the topics we've done. You're not going to see questions on every one of these, but it's just kind of a topic list. Difference between extends and implements. I'm going to say don't worry about implements for this test. Just pay attention to extends. And extends basically says, I'm making a new class. It's got everything that's in this base class that I'm extending. So you're sort of starting with another class. For example, you create a My panel that extends a J panel. All the stuff that's in the J panel is now inside your My panel. And you can leave it like that if you just want a clone of the J panel class, or you can add things, or you can change things. So what do we change? We change the paint method typically because we want something different to happen when we paint. So that's the idea of extending a class. And then implementing has to do with interfaces, and we talked about that, but I'm not going to ask you about that on the exam, because you know we spent like half a class on that, I think. But implementing is similar, except that you don't get any code. You just get sort of a template for different methods with different signatures that you need to write yourself. Deadlock, live lock, yeah, absolutely. And yeah, this is related to threads. usually. So here's a classic example of deadlock. PA5, right? You've got your server and you've got your client. And you hit the start button and you hit the connect button, right? So you're writing your code. And you want to write your event handlers. So in the start code, what do I do? Other equals, some method called read name that reads the name from the other person, and then send my name. And over here on the client side, I have a string other, which I set equal to the result of a method that, reads from a scanner created on the socket and so on and so forth, and then uses the print writer to send my name. Alright, this is going to deadlock. Because when I hit the start button, the server code's going to go into the read name, it's going to go into a scanner, and it's going to be waiting for that scanner object to say, hey, there's data available coming in from the socket. Once that happens, it will read the data, save it in this variable other, and then it'll go ahead and send my name through the print writer. But it's going to wait here until it gets information from the client. Well, the client, you hit the connect button, it's going to sit here and it's going to wait to get information from the server. And it's a classic deadlock because the client is not going to proceed until the server sends its name, but the server is not going to send its name until the client sends its name. And so both processes are going to sit right here waiting for the other one to say something. Right? So you call a friend and you both wait for the other person to start talking, and you just sit on the phone forever. So that's a deadlock. Live lock might be, you call someone up on the phone and you both say hello at the exact same instant. And your algorithm is, if the other person's trying to speak, I'm going to stop talking and wait for them. So you both stop talking because you're using the same algorithm. And now you both say hello again at the same moment, and so you both stop talking for 5 seconds. And then you both say, you go first at the same instant, and you stop talking for 5 seconds. And you never get to the conversation, right? You're stuck in the startup state. It's kind of like live lock. So you're changing state. You're not just, sitting here waiting for something, but you can't get past a certain point. All right, good. So let's rehash threads. So thread is a class that's available for us, and we can create our own class. Let me call it T. And if I say class T extends thread, right? Extends means T has all the stuff that thread has in it. Now threads come with a start method. And I'm not going to define my own start method. I'm not going to override it. I'm going to use the default start method if someone tries to call start in my T class. What that start method does is two things. One, it creates a new process, a new thread. And then two, it calls the run method in this object. So what I'm going to do is I'm going to make a public void run. And then somewhere else, in some class, I'm going to say, T new thread equals new T. Don't call your classes T. That's a pretty weak name. But if I make, an object of type T, and I say new thread.start, that begins the magic, right? So the magic is two-pronged. First, a new thread is created, and then that new thread will execute new thread.run. Right, so I call the start method, which says I'm going to call the run method, but first I'm going to create a new thread. And so now I have this method running in a separate execution context. So it's running in parallel. And then with threads, we get into various interesting aspects. Um, so I don't know, whatever method this is that created this thread, right? This method, let me call this, you know, primary. So this method here knows the identity of the thread. The thread is called new thread. If I want to read the value of a variable in, you know, that object, I can just say new thread dot, you know, counter or timer or something like that. It's easy for this, which created the thread, to access the thread itself. But the thread itself has no direct access to the thing that created it. So, you know, sometimes what we might do is give the thread an object that it can use to access things in this class, the class of the thing that created it, the object. And so we can use, you know, a mutator, for example, to say, you know, save my ID. We can pass the value of this and have an object method in here that takes that argument and saves it, and then it can use that object to, you know, get to things inside here. So we can fangle two-way connections like that so that each thread can access things inside the other. We can do this in really sloppy ways pretty easily. It's trickier to do this in a clean way. And as you may have discovered in PA5, right, doing this in a less than totally clean way can get you into all kinds of strange headaches. It's really helpful if, you know, you have some field in here, a flag, an integer, something, right? It's really helpful if you have a very, very clear idea of under what conditions this can be modified. And if I've got, you know, a bunch of threads and any of them could be modifying it, and I've got a main method that can be modifying it, it makes debugging really confusing, right? So we use accessors and mutators, right, so that we have a controlled pathway to doing updates and so on and so forth. And I guess the general theme might be the fewer things that are able to touch a memory location, probably the cleaner your code's going to be. That's a bogus rule, you know, if you say that's always the case. But it feels like that's kind of a starting point for a guideline. If you've got something in here, don't just have, you know, 5 different classes with code that can manipulate this. Try to contain it, constrain it. All right, so yeah, so we set up threads, and the only other tricky part is this question of synchronizing access. So we did some sample code where, you know, we did I++ 20,000 times, and I did not get incremented by 20,000. And so this was this whole read, modify, write business. And the fact that that's not generally an atomic operation. And so if you have 2 threads doing read, modify, write on the same object, the same location in memory, you can get into this effect where you know, you get contention between the two threads. And so we sometimes need to atomize certain operations, and so we can do that in Java with a synchronize keyword. And we can synchronize blocks of code, we can synchronize methods. If you do a block of code, you just need a flag, right, a shared object that can be used to control the synchronization. If you do a method, you just put the synchronize keyword in the declaration of the method. And then, you know, only one thread will be able to go into a synchronized block at a time. And so you can do your updates of shared variables inside synchronized blocks. Same comment as with threads, right? Write some code and play with this. Write a main method, have it create a thread, make a class that extends a thread, put a run method in, and actually write the code that, you know, creates a thread, calls the start method. You've seen it done. You've gotten it working in you know, PA5. But just write, minimal test case. Strip away all the fancy stuff. Command line, stay away from Eclipse. Just write a minimal test case that lets you flex your understanding of how threads work, how you construct one, how you extend the class, how you call the start method. And that's probably really good practice. Extending on that, general ideas for preparing for the exam, right? Definitely go back through your programming assignments. Those are kind of representative of the kinds of questions that I might ask. I'm not going to ask you to reproduce something you did in one of the assignments, because there wouldn't be much point in that. But that sort of level of question, that style of code. So go back and review your code, but consider spending some time rewriting some of your code, right? Because reading through something and understanding it is totally different from being able to create it from scratch. So if PA4, still feels kind of fuzzy and you never got around to doing a rewrite, think about taking an hour and trying to start from scratch and make a new version of your dots game, right? If PA5 was fuzzy but you like PA4, go back to a clean version of PA4 and try to add the networking again. And do it in a way that makes sense to you. Maybe don't worry about the quit button or the name exchange, just worry about the mouse clicks, or just worry about the name exchange. But practice. The more comfortable you feel writing code, right, the easier this is going to be, the easier other stuff is going to be down the road. All right, so we've hit a bunch of this stuff already. Client-server model, sockets and server sockets, accepting binding using try-catch. So we've talked about that. Deadlock, live lock, we talked about. Synchronize to control access from multiple threads, we've talked about. Threading, start and run using this, we've talked about that. So let's talk about swing and GUIs. So, Window Builder writes most of our kind of gory code for us, so I'm not going to ask you to write, an event listener or write something that sets up the exit operation on a JFrame or any of that stuff that Window Builder normally does for us. But, when you right-click on a button and you say Add Event Handler, and Window Builder fills in some code and then drops you into the editor, and ask you to type some code, you might see that on the exam, right? I might give you a template of code that could have been constructed for Window Builder and say, add some code to the button listener to do such and such a thing, right? Read this text field, increment the value, and write it back, or whatever. So be familiar with, the kinds of things you were doing in working with Swing, but if you haven't had to write this stuff from scratch during the course, I'm not going to ask you to do it on the exam. So mostly, event listeners, action listeners, mouse listeners, button listeners, those kinds of things, you don't have to know how to write those. You have to know how to use them, how to put code inside those to do something. You don't have to know how to construct a JPanel and add it to a JFrame, right? But you need to know how to make your version of a JPanel, how to make a paint method and call repaint and so on and so forth. So things like that. All right, so that's all for event handlers, mouse listeners, button listeners. Definitely understand the paint method. All right, if this is fuzzy to you, go back and look at some sample code. Write some code. Write some code so that when you hit a button, a rectangle pops up on your screen, or when you click the mouse, a circle gets drawn where you clicked. Right, and the main thing with painting in Swing is that we can't just say draw an oval anytime that we want. We can really only say draw an oval inside the paint method of something like a JPanel. And when a button gets pressed, we're not inside the paint method. We're inside a button listener. And we can't call the paint method because we don't have a graphics object. So really what you need to do is the following. Button gets clicked. We come into our button handling code. We set something up in memory and we call repaint. Repaint eventually causes paint to be called, and then paint looks in memory, sees that thing that we set up, and does the right thing. Okay, that's how dots worked. We modify memory, we set flags, we change booleans, right, whatever, and then we call repaint, and that runs the paint method, and the paint method looks at all those things in memory and says, oh, let's draw some dots, let's draw a line, let's draw some initials. So be familiar with that whole process. Alright, so class extensions, we talked about the idea of that. The super keyword is a way to get to the original version of a method, for example. So if we make our own paint method, and then we say, you know, paint, we're going to be calling our method. But if we want to get to the version of paint that was in the original class, the base class, we can say super.paint. And that means the original version of paint, paint from the class that we extended. And we use that typically because, you know, we want to have our paint method do some extra stuff beyond what the original method did. So we call super.paint, that does all the old stuff, and then we just add some new code below that to do the extra stuff we want done. So that's the super method. Scanners, print writers, we've been using those since early on, and we've used them to read and write, you know, to standard in, standard out. We've used them to do file I/O, and most recently we use them to do I/O on sockets. So they're good, you know, workhorse tools. And when you write, normally our output is buffered. If you write to standard out, you don't actually see anything until a new line gets printed. If you write to a socket, you don't see anything even after a new line until, you know, some number of characters has been sent. So we use the flush method to force output to appear immediately. All right, arrays. We can declare an array of, you know, integers pretty easily by just saying, you know, new int bracket 10. But with an array of objects, we have this two-part process we have to go through. First, we have to declare the array itself, but then we have to actually construct each of the things in the array, right? When you declare an array of rectangles, you have, you know, say 10 rectangles, but each rectangle is null. So we need to do the second step where we actually construct the objects in the array as we need to use them. So that's different from primitives. If we want an array of ints or doubles or booleans, lowercase b, right, we can just say, you know, new boolean bracket 10. And that's you know, just an extension of the idea that, you know, if we say something like integer x, we can immediately say x equals 10. And we don't need to use the new keyword to construct an integer. But if we say something like, you know, integer x, and then we try to use, you know, some method inside x, we'll get a null pointer exception, because this is null until we actually construct it, set x equals new integer uppercase I. Strings, definitely know the basic methods for strings. So length to find the number of characters in a string. Equals as opposed to equal equal. Don't use equal equal for strings. Okay, a lot of people got into trouble, you know, trying to detect the quit command and so on by using equal equal instead of dot equals. So if you have strings, string 1 dot equals parentheses string 2 will tell you if those two strings represent the same collection of characters in the same order. Compare to see, you know, which one comes before or after another. Character at, which returns a character at a particular position. 2 uppercase, 2 lowercase, there's a whole bunch of methods. Substring, just be familiar with those. You've got the documentation available during the exam from Oracle's site, but review your string manipulations. And then toString is a special thing that every class has a toString method, because every class is an extension of an object, and an object has a toString method. It has like 5 or 6 methods. ToString is one of them. And when you have an object and you try to convert it to a string, that conversion is done by calling the toString method and using the value that's returned by that. So we can write our own version of toString, and when we take our rectangle and say print it next to a string so it concatenates, it'll use whatever our toString method returns. Particular data structures we worked with. So we worked with linked lists initially, right? And linked lists are really kind of a very general data structure that also include, stacks and queues and arrays and plain old 222 linked lists and so on. But a linked list, we can go in with an index and we can say, give me element 15. We can say, add this to the beginning, add this to the end, remove this from the beginning or the end. So they're kind of a general purpose class, something that's called a collection. So be familiar with the structures that we use. So linked list, hash map were 2 big ones. We made some trees ourselves, right? I think we might have made some linked lists ourselves also. We did some recursion, so all of that kind of stuff. And generics, remember when you construct something like a linked list, it doesn't force you to make a linked list of a particular type of thing. You get to choose what your linked list is comprised of. So the linked list class itself is called generic. It works with different types of data. And so when you declare or construct a linked list, you use angle brackets and you put the type of object in those angle brackets, and you get a linked list of that object. Or for a hash map, you use 2 of those, one for the key, one for the value. So that's the idea of generics. And iterators are a way that we can go through an object and ask for elements inside some sort of collection. So, for example, if you have a linked list, we could, look at the length of it and say, give me the first element, second element, third element, and so on. If we have a hash map, there's no such thing as the first element, the second element, the third element. And if we don't know what the keys are ahead of time, we can't just go through and start pulling data out based on keys. So we have an iterator. And an iterator is a setup that basically lets you say, give me, one thing from this data structure, give me another thing, give me another thing. Oh, there's nothing left. Okay, thanks, I've seen it all. So that's an iterator. And it's styled very much the same way as when we use a scanner. So we can do a has next and a next, and pull things out of a collection by saying, while this iterator has a next item, give me the next item. Not a whole lot to say on the rest of this. So, obviously know how to construct classes, know about methods, constructors, signatures, all that sort of stuff, how to create a class. General Java syntax, basic statement syntax, how to create a main method, public static void main, string bracket args, for example, and all that sort of stuff. Basic concepts of object-oriented programming. Well, you've been doing this for 10 weeks, so I think you know the basic concepts at this point, but we're bundling code and data together. We do information hiding so that the person using a class can see and interact with the parts that the creator wants them to see and interact with, but other parts can be hidden from view, so we can make things private and so on. And that supports the idea of creating abstract data types, where somebody has an interface to our class, but they don't necessarily know or care or are able to interact with the implementation details. And Java's object-oriented. Have we talked about this yet? Java is an object-oriented language. There you go. And it's interpreted, so it doesn't get compiled down to machine code that runs on your laptop's CPU. It compiles down to a virtual machine code called bytecode. that runs on a virtual machine called a JVM. And so it's nicely portable. If you give someone an implementation of the JVM, they can run Java code on it. And that can be on a laptop or you know, a smartphone or whatever. And yeah, so be able to write code, analyze code, fix bugs in code, answer questions about code, things like that. That's pretty much it. That's kind of the whole shebang. Any other questions, issues? This is the point where someone says your microphone is muted. Okay, it's not. All right. Well, let me just leave you by saying, you know, thank you so much for all of your hard work and participation. It's been a real adventure. For most of you, you know, it's been 3/4 of the CS sequence. For some of you, it's been more like 2 years, right? Going back to like 101 in some cases. And I've definitely enjoyed it. It's kind of a bummer that most of you I haven't actually met in person, but you know, we'll get back there, and you know, I'll probably be in the audience at your WSU graduation, which will hopefully be in person by then. And so yeah, just you know, keep coding. You know, we'll come to your final first of all on Monday, but you know, over break, keep coding. Download sample problems. Go to different websites, Project Euler or you know W3 schools or whatever, and keep your coding skills sharp and hit the ground running in fall. So if you're at WSU in fall, there's some intense courses coming your way, and they're really fun. You get into some really good sort of large scale projects at a low level, and so that's good to look forward to. Cool, all right, I will let you out 36 seconds early. Whoa, celebrate. So have a good weekend. Interesting weather coming over the next few days, and then I will see you Monday at 2 o'clock. All right, cool. Thanks again. Have a good one. Take care. Bye.